to our final examples video of term 3. And so this is finishing up our statistics unit, and we are looking at surveying sampling. So with this one, keep in mind that it looks like there's a lot of work, but there's really not a huge amount. It's just really, really wordy. Okay, so if you even look here for a start, this is only part of the example, but because there's so much explanation in it and so many words, it looks a lot larger than it actually is. So for this example, we've got a graph and it's looking at the number of children and then how many times that number of children comes up. So if you look at it, we had 0 children came up 50 times, 1 child 20, and then so on. Okay, so then it was like 15, 10, and then I'd say 5 for that last one. Okay, so it says a survey is conducted asking 100 randomly selected adults how many children they have. The results are shown in the graph above. Okay, so assume that this sample is representative of the population. It's a random sample with no bias included. What proportion of the adult population has 2 or more children? So to do this, I look and go, okay, so what numbers were there of 2, 3, and 4 kids? So here we had our 15, 10, and then 5. Okay, so what I'll do is I'm going to add those together. So I go 15 plus 10 plus 5. And what that gives me is 30. So I'll then put that in a fraction as 30 out of 100. Now what we can do is actually simplify that down a bit because we really don't want to leave it as a big fraction. Okay, and what you can do really quickly is just get rid of a 0 on the end of it, and what you end up with is 3 out of 10. So there's our proportion. Okay, so the next part is, in a group of 9,000 adults, how many would you expect to have 4 children? So as we know before, out of the 100 people, 5 have 4 children. So to work out how we could work out 9,000, what we do is we go 5 out of 100, which can be simplified down to 1 over 20. So I divide both by 5 to get that. So to find out in a group of 9,000, what I do is I multiply this fraction, so the 1 over 20 times 9,000. And that will give me the expected number. Okay, so if you're using a phone calculator or even have a calculator without the fraction button, to do this in a calculator, go 1 divided by 20 in brackets and then go times 9,000. And that'll be the best way to do it in your calculator to get it accurately. Okay, so if you put that in your calculator, so I've got 1 over 20 times 9,000, we get 450. So this tells us that in a group of 9,000 adults, if we turned around and did a survey, we could expect roughly 450 people would have 4 children. Alright, the example continues. So what I've done is I've put a little version of the graph there. So this part says, is this distribution symmetric, skewed, or bimodal? So if you go back to the notes, there was some graphs that showed you how to showed you what each of these look like. And what this one is this one is skewed, and it's skewed because it goes like in a direction like that. So it's skewed, and you can describe this a little bit further by saying which way is it kind of skewed. Is it skewed to the left or the right? And for this one, it's skewed to the left because like the graph is mostly, the higher parts are towards the left. And so that's just a way to describe the shape of the graph. So then our last part, very wordy this one. Which of the following methods of conducting the survey could lead to bias? So in relation to our survey we've done above. So the first method was asking people waiting outside a childcare centre. Method 2 was randomly selecting people at a nightclub. And method 3 was choosing 100 adults at random from the national census and noting how many children they claim to have. So which of these could lead to bias? So I'm looking at this and going, you're asking about children and you're waiting outside a childcare centre. That one is going to lead to bias. Okay, and so for these you'll want to explain how. And it's because if they're at a childcare centre, they're obviously going to have children most of the time, unless it's grandparents going to have a child too. Unless it's a friend or someone picking up the kid for the parent. So method 1, because people at a childcare centre most likely have a child. And then method 2, I would also say, would lead to bias. And the reason why is you're often going to get a lot of younger people at a nightclub, but also if you're at a nightclub, you're actually likely not going to have children because a lot of parents don't have time for it. Yes, some will take nights out, but you're also not going to get a huge amount of parents, especially parents with with 2 or more children at a nightclub. So those 2 would lead to bias. Method 3 would lead to 0 bias at all. It would be the best way to do the sample. So that is all for this one. So just keep in mind, they're really wordy. Just try and work out what it's asking. Okay, and I'll see you guys next term. Bye.